second interview for Weird Gears to our listeners. This is the second episode for Uddering Engineers Weird Gears series, and we're going to be interviewing Ratik Kapoor. He's also a member of ESS, and I think it's best if he introduces a little bit about himself before we continue.
Yeah, absolutely. So, hi guys, my name's Ratik. I'm the Technology Commissioner on the Engineering Student Society. And then what I also do at school is I'm the team lead at the Relectric car team. So we convert normal cars over to electric, and we try to make that whole process a lot cheaper. So currently over summer, I'm interning at Versa Networks in San Jose. And apart from that, I'm really interested in lots of biomedical stuff.
Oh,
Heck yeah, biomedical stuff. That's the way to
Biomedical,
go.
yeah.
but what kind of stuff interests you in biomed? Like why and what?
Yeah, I guess about biomed, it's something I found fun for a really long time. Because I think engineering, when I first went into it, I didn't really consider biomedical that much. But now that I realize that like there's so much tech that can be used in biomedical, and like we know how to apply that tech and use it for biomedical stuff, I find that it's something that I've really gained an appreciation for.
Sweet. Have you gotten a
Yeah.
chance to work on any projects or like?
Yeah. So last year I was part of the Innovate for Health hackathon, and then what my group actually did there was currently there's kind of a big problem in some countries around the world where patient documentation isn't as good as it should be. And the reason for that is they're not using computerized systems. It's basically people show up with their own records, and the doctors don't know if like everything is correct or if they're missing pages, that kind of stuff. Um, and the real issue is because they don't have reliable internet access, is how can they have some sort of database of patients that works for every hospital, right?
Right.
Um, so what our group did is we sort of took this patient data and we designed it to be in sort of a asynchronous system where each hospital has a copy of a patient's data electronically, and then they're given um, their own data on like some sort of a chip or a card, and the patient carries around their data all the time, right? So let's pretend that I went to the doctor's office, just a regular checkup. The doctor wanted to update a few records on me. They do so on their computer. I plug in my card, and now we both have updated copies of the record. But next time, let's say I'm not in the same location anymore. If I want to go to some other doctor's office, maybe they haven't gotten a chance to communicate with each other and they don't know that my records have been updated. So I have my card with me. I'll walk into the other doctor's office, plug in my card, and then suddenly their local database is updated as well. So now we have, even though they're asynchronously being updated, we still have the most up-to-date information on that card, which all doctors can use. And let's say if you lose your card, we designed it to be really inexpensive. So you could just go to the last place that you visited and just grab a new one from their records.
Wow.
That's really cool.
That's super
Yeah, yeah,
cool.
yeah,
Are you
yeah.
still working on this project or like
No, unfortunately, not anymore. We worked on it until about mid-Decemberish, and then it did kind of fizzle off. But it might be something that might come up again during maybe this I4H hackathon or something. We'll see.
Yeah, I'm not too sure if they're running are they it's going on again this year, right?
It might be virtual. I'm not too sure right now.
Okay, well, small shout out to I4H because it's super fun.
It is. It is really fun. Yeah.
So yeah, for people who don't know, because shameless plugs are kind of one of our favorite things to do here. Is it's innovation for health is essentially you get problems or issues submitted by health professionals that are brought to a group of multidisciplinary like teams, like with engineers, with medical students, whatnot, and they form a group to solve these problems from like more of an engineering lens, and it's super fun. I
Yeah.
did it
It definitely
before
is
as
really fun.
well.
Mhm.
Yeah, I don't think they require too much experience with like the biomedical
No.
field at all. Like before you did I4H, did you have much other experience, or was it this was kind of your first foray into
Uh,
biomedical
I
applications?
Yeah. So in terms of biomedical applications, iFreach was definitely one of my first steps. I literally just saw one of their posters on a wall, and I thought, hey, this would be fun. So I got together a few friends, and we decided to go for it. We all ended up being on different teams, but it was still really, really fun. And it's kind of what got my foot in the door. And now I do like biomedical research and all that kind of stuff too.
I'm honestly just fascinated. I'm trying to process all this information.
Yeah.
It's awesome. So,
Yeah.
I guess since we're talking about biomed, um, are you in the specialization or the minor or?
No, no, actually, I'm not in either of the things. So I'm full electrical with a computer minor, and that's it. I find that I wish I could do the biomedical specialization or minor, but unfortunately, you can't do two engineering minors.
Yeah.
But I think just like through research and just trying out hackathons and that sort of stuff, you kind of gain that experience of doing biomedical things anyway. So I think it works out fine.
Yeah, and I think this brings up a
Yeah.
good point for any of our listeners. If you don't make it to the specialization or minor or major or whatever happens, um,
Mhm.
it doesn't mean you can't go into that career. There's always a way. If you need to talk to somebody about it, there's Ratik.
Yeah, there you
I'm
go.
just
Hit me up.
voluntold. Sorry about
Yes,
that.
it's all good.
But you also mentioned like getting into you're in electrical engineering. What kind of path did you take to choose electrical engineering, or why did that one, interest you or call you the most out of all the different types of eng that are out there?
Yeah. So I think my path was kind of unique in that before I came to university, I knew I wanted to do something electrical. Um, so how I sort of got into tech and computers and all this sort of stuff was, I guess, kind of started in grade five. I just joined this club for fun that would go around and help teachers with their computers, right, during lunch hour. And then we were called the Sherpas, which stands for Students Helping Everyone, and I forget the rest, but it was something tech related. So we were the Sherpas that would go around and help the school with their tech. And I started to really love like networking and just learning everything about how the computers worked and how they communicated with each other. And then eventually, when I went into like middle school and high school, I got like a Raspberry Pi. Um, I think when I got my first Raspberry Pi, it was like December of 2012 or something similar. So what I thought I just wanted to do projects and make little emulators, and I thought at that time a big project would be download an ISO file from the internet, flash it onto my SD card, and say, "Oh my God, I built an emulator!" Right? Like that was cool to me at that point.
Nice.
And then later on, I was like, "Hey, what are all these like pins used for?" So I started playing around with the pins, and eventually got my own breadboard, learned how that worked, and then just kind of kept building on projects from there. Just like small stuff, like I'd press a button and this LED would come on, but at the time it felt like magical, right?
Yep.
Um, and then eventually got into Arduino, as I think most people would do when they get a Raspberry Pi. And that kind of brought me into embedded systems or just like small microcontroller things. Um, and then from there, I guess we learned more about the stuff in university, and I started to find applications for what I was learning, like out in the real world. And I thought, hey, why don't I just take what I've learned already from these like fun but like kind of useless projects and actually apply it into something that's really interesting, right? And that's actually being used.
Well, out of all those like little useless
Mm-hmm.
projects that you've done,
Yeah.
what's one of your favorites that you ever put together?
Oh, I think it would be a failed attempt. Or actually, before I do this, do you guys know what amiibos are? Like the Nintendo amiibos?
Yep.
Yes.
Yeah, yes. So those use RFID, right? And then what I ended up doing is like, I wonder if I can clone these amiibos into just like little cards and see if I can just make a bunch of amiibos and me and my friends can just use them, right? Uh, so what ended up happening was,
Nintendo just
Damn.
yeah. So I bought a card reader. I bought the completely wrong type of cards, and it just the project completely utterly failed. But I was like, hey, this is kind of cool. Like I got to learn how SPI, like the SPI bus and everything works, which for people who don't know what that is basically how different chips on like a circuit can communicate with each other. So that was actually like a really good learning experience, especially because it failed so many times. I was like, man, I got to understand what's going on here rather than just copy paste the code.
It always starts with copy pasting code.
Yep,
Always.
yep.
I think that actually brings up a good point, right? Like
Yeah.
the reason you were successful or are successful in the work you do is
Hmm.
because you just started off fooling around. You're like,
Hmm.
this is something interesting. Let's just
Yeah,
push a button and see what happens, right? And I think
yeah,
at least for me in a lot of those cases, I was like, oh, I don't want to press that button. What if it blows up? Like I'm scared. But I think you bring up
yeah,
a good point there. Like
yeah,
starting trying to start as early as possible, just being inquisitive and like curious and be like, what
yeah,
happens?
yeah. And honestly, like it's good that you bring up what happens if it blows up
Yeah,
because it literally has on me before.
yeah.
Oh shit.
Wow.
Like I think you guys would know this joke, but in electrical engineering, they have it's a very common joke where all these chips run on magic smoke, and if you happen to overload it a bit, the magic smoke comes out and it stops working.
Mm-hmm.
Yeah, one of my professors calls it the holy smoke.
The holy
Um,
smoke.
yeah.
Does it smell like
So,
burning to you? Uh-oh.
oh, yeah. So during one of my card reader projects, I actually did ended up burning a whole Raspberry Pi. Uh,
Wow.
yeah, yeah, yeah. The reason
That's
for that was a few things that led up to it actually. One, it was cold outside. Two, I was bypassing all the voltage protection and it just plugged straight 5 volts into the pins.
Right.
And then three, I was wearing socks on a carpet. So
Ooh.
you kind of see where this is going.
Yep.
Whoosh, and then suddenly,
So, folks, word of advice: no more socks.
yep, yep. Or just ground yourself properly.
Oh
get those
man.
anti-static bands going.
Oh yeah, oh yeah.
I have a question for you though. So
Hmm. Hmm.
I find that like that inquisitive mindset, that curiosity of like, oh, let's try and see, what happens, and that like a level of
Hmm.
creativity of like, how do I, use this RFID for something that my friends and I can do?
Yeah.
Did that come from somewhere? Were you always that creative, or was that something kind of recent?
Uh, I don't know if I could like define myself as creative per se, but it's just been I want to fool with one thing, and then now I want to play with another thing, and then eventually, like when you've played with so many things, you can start putting connections together and be like, oh my god, I could do this big project that actually does stuff using this all this like random junk code that I have laying around.
Sweet.
Right? So I don't think I was like trying to be creative specifically, but it
Right.
just sort of happened to happen like go that way.
That makes sense. And
Hmm.
and I'm assuming that kind of same thought process is what like produced Reelectric. Is that kind of
Yeah,
how it
yeah,
happened?
yeah. Kinda. Well, the biggest thing was I got to sat in a or I got the opportunity to sit in an electric car. It was a Tesla Model S. And then yeah, there you go. Yeah.
I love those.
I love those so much. And then I was like, wow, that was amazing. And then I looked it up and I was like, wow, I can't afford this. Right?
Yeah.
And then I looked into some other electric cars like the Volkswagen e-Golf and stuff like that. And I was like, wow, these are amazing. I still can't afford them. Right? So I looked up like what makes electric cars so expensive, right? Because at the time I was on the solar car team, and then like I know like some of the stuff that they buy is just absolutely insane in how expensive it is. Like some of the solar panels are up to like 100 grand, right?
Yeah.
Um, I was like, okay, it makes sense. These guys are using like cutting edge solar panels, but what about like a production car? Like, why is this stuff so expensive, right? And then some of the components, like the battery controller and the motor controller, that stuff is just like insanely expensive. But like what I thought coming from like an embedded systems background is we could probably try to put our own thing together using some of the newer technologies out there and let's try to make it more efficient or cheaper, right? More accessible, really. Yeah, and then our why we chose to convert cars specifically. Um, First of all, there's a bunch. I forget the exact number, but there's a bunch of cars that get scrapped and all that stuff, just straight to the junkyard that are perfectly fine except for like a few motor faults or something, right? Um, so what you could do, let's say in theory, I go to the junkyard, I see some '08 Civic. Um, oh wait, Honda Civic, it's probably gonna cost me around $500 to buy from the junkyard, right? And then what I could do is I could bring that home if it was affordable to convert that car within like $8,000, $9,000. I could just gut the engine, sell all the parts that work good, and kind of make up that cost, and then put all electric components inside that Civic. And now suddenly I could potentially have like an electric Civic in under $10,000. So in that way, we've not only prevented waste by bringing something back from the junkyard, but at the same time we're using something that's more efficient to get around and in my opinion more fun, right?
Right.
So basically the premise of Relectric is how can we make that situation possible? So like all the work that we do, everything we try to push it as open source as possible. You can find all of our software on GitHub, and then we eventually our goal is to encourage people to use whatever resources are available to them to kind of create an electric car of their own and make it more affordable for people. So eventually get that community going.
Wow. And hence
Hmm.
re-electrifying something that already
Yeah,
exists.
yeah, exactly, exactly.
Nice. Yeah,
Yeah,
dude, inspiring. I'm not even joking. Like
yeah,
wow.
yeah. Thank you, thank you.
It's awesome.
Mhm.
So, are you looking for members or stuff? If somebody was interested in joining Reelectric,
Mhm.
how would they go about doing that?
Yeah, a few ways. Depends on whether or not you're at UFC. Um, this hasn't been announced yet, but I can say that an announcement is coming. There's a big American university that's joining Relectric, so they'll be our first outside of Calgary branch. So that's going to be really really exciting.
Wow.
We'll post more stuff on our LinkedIn closer to. Um, but yeah,
Congratulations.
if you wanted, yeah, thank you, thank you. So if you wanted to join from another university, definitely do it. Reach out to me because we're starting to develop this community of universities and people who just want to be involved in the conversion scene. If you're on UFC, we're hiring in the fall, so there's going to be lots and lots of opportunities there. So just again, message me, or if you have me on LinkedIn or something, I'll definitely be posting our applications there.
Awesome. And what kinds of
Yeah.
opportunities can people look forward to?
Yeah, so you could either, there's a few teams that we have that you could join. Each of them are pretty unique in what they do. Uh, First, I guess, is mechanical engineering. That's kind of the obvious one. You're trying to convert a car, you need to have the mechanical parts to do it, right? Electrical is the other obvious one as well because you're building an electric car. Hopefully, you have a few electrical engineers on your team. Uh, but then we also do have a business team. So for people who are in like a business role and they want to get some like actual real world experience of like reaching out to companies and doing or getting sponsorships and that sort of stuff, they're always welcome to join. We also have a software team and a geomatics team, and I'll explain why now. So if you can, like I said, going back to the Honda Civic example, let's say I converted my car, but at the end, after I converted everything, I still have an '08 Honda Civic, right? Nothing's really changed,
Hmm.
right? It's just got an electric motor in it instead of a gas engine, and that's about it. So what our software team is doing is they're taking all of these components from custom conversions and they're tying it all together in some common interface. Like let's say what a Tesla would have, or what your any modern car would have some nice big screen as their center console. What we're trying to do is achieve that same effect, but for converted cars. So let's say like we're converting I forget the exact model, but it's a car from the 60s. So what we're able to do with that car is take all the stuff that we've converted and then tie it all together into this common interface. And then it'll basically be like an iPad or like one of those Tesla screens just on a Volvo that's from the 60s.
Dude. So
Yeah.
basically
Hmm.
having like a modular electrifying
Yeah.
like approach
Yeah,
to doing that's
exactly, exactly. And just getting all
awesome.
the modern amenities onto there, which brings me to why we have a geomatics team. So I don't think there's any other team at Schulich that has a geomatics engineering team. Um, I don't know if you guys can think of anything, but
Uh,
I certainly can't.
I think
Um,
SOAR
yeah.
or any of the aerospace
Oh,
kind
do
of
they?
related teams. One of them, the UAV team, I believe, has a few
Okay,
geomatics people.
okay.
Yeah.
Yeah, yeah. No, that's it. That's really good. But what we see in like a geomatics team is all of the modern sensors that cars have, like collision detection, parking, whatever, or like lane departure warnings. Those sensors are all kind of what geomatic students do, right? And like all the sensory and spatial awareness stuff.
Right.
So we're kind of unique in that we're building all of this like collision detection or like lane departure warning stuff, and we're building it using cheap equipment. And then we're also integrating it into that common system that I was talking about earlier. And we're doing it for converted cars. So at the end, let's going back again to the converted Honda Civic. I don't just have a Civic sitting with me now. I have like basically a modern car with the same kind of like safety, I guess, with like collision detection that a modern car would have, but just tied together in an experience that's like affordable for everyone.
I love the approach, like super
Yeah.
super sustainable on every
Mm-hmm.
front,
Mm-hmm.
super innovative, and I like the fact
Yeah.
that you're involving multiple departments in the
Yeah.
project. The only
Mm-hmm.
sad thing is, as biomedical engineers, a little room for us would be great, but otherwise it's great, dude. It's awesome to
Yeah.
hear.
Yeah. Yeah. Yeah.
How many
Mm-hmm.
car conversions have y'all completed thus far?
Well, we started the team last year.
Hmm.
Actually, around this time was when we founded it. So we're on our first car right now. Currently, we're just using like kind of off-the-shelf components to get a sense of how it's all put together. It would have been driving by now if school didn't get shut down because of COVID. But what we're hoping is once that conversion is finished, then we'll kind of remanufacture it with our own components, and then we can drive it around, see, and then we can basically see how much like cost we've reduced or shaved down from that conversion, right? So first go for that version 1 and then go for that version 2, and then after that we can kind of see what other cars we can branch off to.
Right.
Mm-hmm.
Oh, that's so
Alright.
exciting.
Yeah,
Yeah,
I'm gonna shift gears a little bit on this. I'd still talk
oh,
about Reelectric,
That's a
but
that's a good
that
transition.
a different part of that experience. You started the team, the club, right?
Yeah, yeah,
Came
yeah.
up with the concept, put the team
Mm-hmm.
together. What was that leadership experience like? Like walking into a new technical team, not really
Yeah,
like having a vision, but not really knowing
yeah,
what to expect out of that first couple years.
yeah, yeah, yeah. I mean, at first is like it's something that my friends and I were thinking about. Hey, this would be a cool idea to start off as a club, but like in first year. And then we decided that hey, let's really follow through with this. So at first, it was definitely super interesting, just having like so many people who are like, hey, we're ready to join and we're ready to do stuff. But then at the same time, it's so much pressure because people are willing to give you like so much of their time, and then you really have to make sure that you're like, I have to follow through with what everybody's committed to me, and make sure that we actually like do the stuff that we're supposed to do. And
Right.
there's been like so many challenges. Like at first, we first pitched the idea and it was well received. But then when we went on to get funding and everything, people wouldn't believe us. They're like, okay, you're a team that just started. You don't have a car, you don't have a space, you don't have any funding. How can I, in good faith, give you some money or some seed money when you have no history of doing anything, right? Because we were starting completely from scratch. And the first few times that we applied for funding from anywhere, we got rejected. Um, so what we did to kind of combat that was we started putting partnerships together, and then we found a community partner that Go Electric, actually they were interested in sponsoring us, not only with a space but with their car as well. So the Volvo that I was talking about earlier, that we're converting right now, that's actually one of our sponsors cars, and then he wanted to convert it but never was able to follow through with that conversion just because of time constraints. And when we first went to go meet him, he basically just pulled out the cover from the car. He's like, "Hey, this has been sitting here for like like a year, and I want to like get this converted, but I just can't find the time to do it. Why don't you guys do it?"
Nice.
And we're like, "Yes, absolutely, let's do it, right?" So that's kind of where things started like taking off really seriously, because now we had a car, we had a space, we'd found components and all that stuff as well.
Right.
And now suddenly we went from being not a viable club to everybody's super interested in us.
Right. Now you have something
Yeah.
to show for, right?
Yeah, exactly.
That makes sense.
Hmm.
Yeah, I can't imagine, like, personally, if it was in that situation,
Yeah.
it's pretty intimidating. Like, I don't know.
Yeah.
I'm not saying I'm gonna give myself a little credit. I'm not saying like I can't handle it, but I'm saying that like it's pretty intimidating. Where like, okay, somebody just give me a
Hmm.
car. I got a little bit of
Hmm.
money and I got a ton of people. How
Yeah.
do I make sure that first of all their time is valued? I look like I
Yeah.
know what I'm doing,
Yeah.
so that there's that level of trust the entire way through, right? And then how do I
Yeah.
provide value to these people by the end of the cycle, right? Sometimes it's not like
Hmm.
I can't deliver you a car a year from now, but
Hmm.
I can deliver you some decent code, a plan, a concept, and a couple of these things, and people with some
Yeah.
experience, right? Like, how do you
Yeah.
convince that person in front of you that, this is still valuable? We're going to get it done, but maybe not
Yeah.
right away.
Yeah, exactly. And I think like once you find people that kind of start to share your vision, they get, I think the most important thing is to get other people excited about the stuff that you're doing. Like get other team members excited or even get like sponsors excited for stuff that we're doing.
For
And
sure.
just kind of share the hype that I personally have. And I find that tends to just motivate a lot of people.
For sure. And
Yeah.
I have to give you credit for that, in the sense that like you make it sound very easy to like get people to share your vision, and like people are supportive, but it's very hard to like
It
have
is.
people believe in your vision and clearly
Hmm.
identify what your vision is and support
Hmm.
your vision and get money and all that. Like, kudos to you, dude. It's a
Thank you. Thank you. Yeah.
great project, great initiative,
Yeah.
super
Yeah.
inspiring. And now you got
Yeah.
that American University. By the way, that's an exclusive for our podcast to any of our listeners.
Yes, yeah, you'll find out who it is soon through our LinkedIn.
Wow. Wow. Awesome.
Yeah,
Yeah. Really looking
yeah,
forward to that. And
yeah,
once it's posted, do you mind if we share it with our listeners in the description?
yeah. Absolutely, absolutely.
Awesome. Awesome. So I wanted to say thank you to our listeners for listening to Ratik's our interview with Ratik.
Mhm.
He's super inspiring, super well spoken, and a very hard worker. And we're really proud to have him both on ESS and as one of our guests here. So thank you for joining us, Ratik. And if people want to come in contact with you or Reelectric or have any questions, how can they reach you?
Yeah, yeah. So first of all, thanks so much for having me on. It's so much fun talking to you guys. And then if you ever want to talk to me, I can give you my LinkedIn, and then
Awesome.
just feel free to connect with me there and message.
Awesome. And we'll add
Yeah,
that over down in the description. And just
yeah.
to wrap things up, thanks again. If you want to contact us for ESS or just the podcast, you can find us on Instagram under ufc.ess. Same for Facebook, or you can just search up University of Calgary Engineering Student Society. You should be able to find us. If you want to contact me to ask any questions directly, you can find me at ashshevek1 at on Instagram. And feel free to give us feedback, information. We really want to hear from everyone. We want to learn how to grow and work with this. And if you want to hear from someone that is not Ratik and is somebody else that inspires you and is another interesting guest you want to hear from, let us know and we can try bringing them on.
Yeah, we're also looking for people to help out with the podcast, someone to do some research, and someone to help edit these interviews as well. So if you're interested, please let us know, and we'd love to have you on the team.
Thank you for listening to episode 2 of Uddering Engineers, the Weird Gears interview series with Ratik Kapoor.